So I'm just going to do a brief overview just of what crowdsourcing is, and then each of our panelists is going to talk about specific aspects of it or specific projects. So a really generic definition is it's asking a group of people to accomplish a task or solve a problem. And that can mean a lot of things. The group of people could be anyone on the internet. The task could be something from, could you categorize these pictures for me, to I have this really cool project. Will everyone donate $1 towards it, or something like that, like you would through Kickstarter? Can you locate these objects, translate this text? It can really, really vary. And it can vary almost as much in disaster risk reduction or disaster response as well. Anything that you can break into little tasks that you could get people to do. So reminder, you can shout out your questions at the appropriate time, or I'll call on you, or you can tweet them at pound UR crowdsourcing. And so we have five panelists other than myself. I'm Kate Chapman. I'm with the Humanitarian OpenStreetMap team. We apply OpenStreetMap to disaster response and disaster risk reduction. We're going to have Robert Monroe, who's a linguist, who's going to talk about some of the, he's focuses on processing digital communications, and has a PhD from Stanford University, and helped coordinate mission 4636. After that, we have Emmanuel Kala, who is a software developer at Ushahidi, and he's currently working on Swift River, which is a project to take data and help organize it and verify it, and present in meaningful ways. Then we have Shannon Dozmagan. She's a co-founder of the Public Laboratory Group. The Public Laboratory, she'll talk about it more, but it focuses on low-cost equipment for citizens, such as balloon mapping or creating sensors to have information about environmental data. After that, we have Helena Pugh-LaRue. I just unfortunately butchered her last name. So she's one of the founders of the Standby Task Force, which is a large international volunteer group that helps process information. And previously worked in conflict prevention with UNDP in Sudan. And finally, we have Abby Baca, who's with the World Bank. She's part of the East Asia and Pacific Disaster Risk Management team. And she's been consulting for the past 1.5 years with the Global Facility for Disaster Risk Reduction. So first up, we have Rob.
Thank you, Kate. Hey, how's everybody? So like Kate said, among many other things, I'm a trained linguist, and when I come to places, I like to find out something interesting about the languages which are spoken there. So I think a lot of people at this conference who have come in here from elsewhere have been silently sharing this one thought, and that thought is, where did all those clicks in Xhosa and Zulu come from? Right? So you're hearing these incredible languages, and they have clicks in consonants, which is not a widely found linguistic trait. And the answer is Nguni languages, or perhaps just one language, Proto-Nguni. About 500 to 1,000 years ago, speakers of Bantu languages, which do not have clicks traditionally, moved into the area of Khoisan languages, which do have clicks, and borrowed some syllables from these languages into their own. And this is actually a cultural tradition on top of a cultural taboo, which was to avoid using the names of in-laws in any possible context. And I think that's probably the oldest form of risk management that we have, to avoid talking about the in-laws. So now you know. Okay, that's not what I'm talking about. I am talking about talking to the crowd in all 7,000 languages that we have in the world. So information is increasing. I think this is well understood on the back of technological advances. But the diversity is also increasing in a way that is less well understood. And one way to look at this is to think about how many languages could you encounter on a given day, and how has this changed over time? So if we go back just a couple of hundred years, people on average spoke 2 to 3 languages, and they could probably encounter 2 to 3 more languages on a given day. So, you know, people in their village happen to speak a different language, traders come in through neighboring villages, etc. This changes really rapidly on the back of radio and the telegraph, and then right now that number is at about 5,000 languages. So you could find speakers of 5,000 different languages on the other end of your cell phone right now if you just dial the right numbers. And this is actually going to drop off. We're losing between 50 to 90% of the world's languages within the next 100 to 200 years. So we're in this very thin sliver of time where we can have such diverse conversations, but we have so few resources to do it. And so I think that in some ways, putting a phone in the hands of everybody on the planet was the easy part, but understanding what everybody is saying is going to be much more complicated. And this is because for 99% of the world's languages, the languages which are currently taking part in digital society, we don't have machine translation or similar services like comprehensive online dictionaries. And if you're a speaker of what's called a low-resource language, then you are disproportionately less likely to have access to healthcare and education, and you're disproportionately more likely to be exposed to disasters, both man-made and natural. And crowdsourcing is one method that we can use to bridge part of this communication gap. So I'm going to talk about a few different projects in my speech today. So Epidemic IQ, I was the CTO of this project last year. I was tracking epidemics globally. I coordinated Mission 4636 in the wake of the earthquake in Haiti. We're talking about it. And then also we're talking about PAC Report, which was a similar but much smaller system deployed in Pakistan, and Libya Crisis Map in Libya. So I was the architect of the system in PAC Report and contributed to Libya Crisis Map. Okay, so Mission 4636 in Haiti was a crowdsourced processing system that translated messages in real time from Haitian Creole into English, the language of the international community who were coming into Haiti in the wake of the earthquake. It was translation was the main task. It was also filtering and geolocation. So, for example, a message would come in to a crowdsourcing platform. Delilah here in San Francisco might read this message and see that it has a location, Thomason, which she needs to geolocate on a map. Apple in Montreal, so these are transcripts from an online chat room, knows this place. And as he says, this is not on Google Map, we have no streets here. But he's able to click on this location because although he's currently in Montreal, he grew up in this area. He knows exactly where this is. And so even though there's no online resources which show where this location is, his local knowledge, even from a continent away, is able to be employed immediately. And it's easy to demonstrate the importance of local knowledge. So just imagine that even if you had a good translation from Haitian Creole into English, and you were to identify the village of OCAP. So can anybody see OCAP on this map here right now? No. What if I zoom in? No. Okay, I'm gonna zoom in once more. No, you can't see OCAP? Okay, OCAP is slang for Cap Haitien. So it's been one of the biggest labels on that map the whole time, but unless you knew that OCAP happened to be Creole slang for this location, it was going to take you a lot of time to discover this, especially because a lot of the online resources we use tend not to have slang terms for publication conventions. And your local knowledge might also tell you that the Sacred Heart Hospital is actually 14 kilometers south of Cap Haitien in an even smaller village called Malat. And so this is one way where it's really easy to demonstrate that you need local knowledge. And we can actually do the math on this from the deployment itself. So in Mission 4636, we had both volunteer and paid Haitians who mapped about 45,000 messages, map translated and filtered, with a median turnaround of less than 5 minutes each. So this is equivalent of about 5 novels, pretty much translated in real time in a language that few people, even in the response community, had heard of before the earthquake. And we can compare this to other crowdsourcing deployments which didn't involve Haitians and were just using the existing online materials, who processed about 3,000 messages at greater than 4 hours each. So this really shows you what the benefits are in employing local knowledge, wherever in the world that local knowledge happens to be. So lessons learned from this project. One is defaulting to private data practices. So it's actually a majority decision on Mission 4636 by the Haitians not to put this information on a public map because it contained the personal identities of at-risk populations and included minors. Find volunteers through strong social ties. So we're actually 10 times larger and faster than some more well-publicized efforts at the time, like Ushahidi Haiti. And I think one of the main reasons that we're able to be so much bigger and so much more efficient is that we reached out to people through their existing social networks, and we didn't tie our information processing to the media arc, which caused some of the more well-publicized initiatives to wind down when the media wound down, rather than when the need on the ground itself wound down. Something I've seen a lot is the first people who are local who will want to work with you tend to be activists. And they may call themselves activists or bloggers or crisis mappers. So obviously not all bloggers or crisis mappers are activists and vice versa. And they're all some of my favorite people. But anybody who comes to a project like this with their own agenda for what information they would like to put out there, often contrary to, say an oppressive regime, are people who aren't in the best position to make decisions about what data should be public and what shouldn't be. So while it's great to engage a crowd, you might have to proactively avoid the people who are going to bring their own agendas and might be prepared to expose other people's personal information for their own political gains. And also localize to the crisis-affected community. So 25% of all work were by paid workers. And these are actually workers in Mirabelais, Haiti. So who has heard of FATEM? It's an NGO in Mirabelais. No one? Okay, who's heard of Ushahidi Haiti before? Okay, so yeah, most of you. So FATEM were the single largest NGO contributing to the crowdsourced response to Haiti, and they were by paid workers within Haiti, and yet no one has heard of this story before. I think there's been a real imbalance in the reporting to date, and I think that paid workers within a country who remain employed to this day get in jobs to bootstrap their own recovery, and I think that's the more interesting story. Not to take anything away from the great efforts by Ushahidi Haiti. And so because we paid them, we have benchmarks that we can use. So 25 cents per translation of a text message, 20 cents per geolocation, 5 for categorization or filtering, and an average turnaround of 4 minutes per report processed. So when you're evaluating whether or not you want to use paid versus volunteered crowdsourced workers, we can use these as our benchmarks. So moving to Pakistan, so this was data structured in a similar manner in the wake of the 2010 floods there. And instead of giving each task of geolocation to one person, we gave it to multiple people and then took the centroid weighted by our confidence in each of those workers. And we're able to demonstrate here that even 2 inexperienced workers, on average, the weighted locations that they found were better than using one very experienced worker. And this is actually the norm in industry. So when you have crowdsourced workers, you give the task to multiple workers and collate across them. So the lessons learned here are, again, defaulting to private practices. We had the Taliban actually make threats to aid workers in locations that we had mapped and published. Cross-validate, as I just said. And again, localize to the crisis-affected community. So we're able to create jobs with Impact Report with an organization called Brightspy, who are still employed to this day. And a lot of the most important data we got was not actually open data or reporting by SMS. It was someone in Pakistan who went around and bullied the different aid agencies and got important information from them that we were able to then structure. Not bullied, sorry, formed partnerships with the aid organizations. This hasn't been recorded, right? Okay, epidemics, moving on to another project. So this was a project we're moving on beyond purely manual processing. So disease outbreaks are the world's single greatest killer, and no organization is tracking them all. Not many people realize that. They just assume that someone like the CDC is tracking all the world's outbreaks. They're actually not, and it's a really hard task because information is in so many different areas. So in the last 75 years, we've only eradicated one infectious disease, and that's smallpox. But the increase in air travel has increased significantly. I mean, I think we have people here just in this room from every single continent who have shared planes in the last couple of days with a very large number of people, which makes me glad I'm standing at this distance from you all. Okay, interesting fact here, 90% of the world's ecological diversity and 90% of the world's linguistic diversity are in the same parts of the world. So this is a linguistic problem because most of the diseases are going to come from the tropics, and they'll be first discussed in any one of thousands of languages. We can see this. So we can go back and find reports of bird flu weeks before it was identified as a new potential deadly illness. For swine flu, it was months. For HIV, it was decades. So simply finding these early reports, often in open data, can help prevent epidemics. So I won't go into technical details here, but Epidemic IQ was a system which combined automated methods using artificial intelligence and natural language processing with paid microtaskers in the thousands to structure information about epidemics in a very large number of languages. So whether it was Russian, Arabic, Chinese, or dozens more. All with the goal of supporting a very small number of in-house analysts. And we're processing about 1 billion data points a day at our peak. And we can look even in developed nations. There's an advantage here. So the green line is us, and tracking E. coli in Germany, just using artificial intelligence to quickly process very large volumes of reports in the first few days, meant that we're able to get ahead of the ECDC, so the European Centre for Disease Control. Lessons learned, again, in privacy. Current privacy practices are insufficient. So you might report in a medical journal that a girl of a certain age in a certain village tested positive for Ebola. This was an actual case that we saw. That's fine if it's reported in a journal 6 months later. If that's reported in real time and you have the name of the village there and the people in that village know that only one girl has gone to hospital, then that's not anonymized, and that's personal identifying information. And we saw this happening in areas where we knew people who contracted diseases were vilified for carrying those diseases. So I think we need better privacy. So crowdsourcing can provide needed skill sets. So beyond scalability, what organization had hundreds of German speakers at short notice to process those E. coli reports? We're able to leverage that through crowdsourcing. And natural language processing can scale beyond human capacity. So especially let us filter out the millions of reports which weren't vital to us. So I want to talk about a negative example here. And when I say negative, this is just in terms of information processing, not the outcomes of the project itself. So Libya Crisis Map was launched by UN OCHA in the wake of the uprisings in Libya. So it consisted of 283 reports from already open English sources. And this was collected over 1 month of full-time management with contributions from hundreds of volunteers. So we can actually apply those benchmarks which we established in Haiti, and we can see that the equivalent cost to pay paid microtaskers rather than volunteers would only be about $600 or $800 if we wanted to add multiple verification steps. Or the equivalent time if we just had volunteers from within the Libyan community would have been 152 hours, which is actually a little bit less than 1 month at a 40-hour week. And this would actually also address some of the security concerns. So I think the lessons learned here is that crowdsourced volunteers were actually not required for the Libya crisis map. I know this is held up as a success. I don't share that belief. It cost more to run than was saved. I have no doubt that the UN spent more on salaries than they gained by having online volunteers. And a single in-house Libyan could have processed more information. And again, the lesson which was relearned was defaulting to private data practices. So we have to assume that all the identities of volunteers were exposed. A lot of people who we couldn't really vet came in and volunteered and were able to see the identities of all the other volunteers. And as with Haiti, the Libyans who were working with us actually opposed the public map. It was a private map to begin with, and many of them stepped away when it became a public map. Okay, so crowdsourcing and risk. People's real-time locations are the most sensitive personal information, more so even than their names. Crowdsourcing distributes information to a large number of individuals for processing. Since Mission 4636 in Haiti, I feel like I've spent most of my time trying to convince people that crisis mapping and crowdsourcing might not actually be a very good marriage for this reason. And I thank Kate for still inviting me to be part of this panel, despite this. And so my advice would be, for information about at-risk individuals, well, is it right to crowdsource the processing of this information, and is it right to use a public-facing map? Neither of these are a requirement for geolocation of crisis data. So recommendations, engage people with local knowledge, employ people with local knowledge so you can guarantee your workforce. It may turn out to be cheaper. Statistically cross-validate on the fly. So as you saw with Pakistan, that improved even for non-professional workers. Default to private data practices, and scale via natural language processing when you need to go beyond thousands or tens of thousands of reports. All right, thank you.
Yes, good day, everyone. So I'm going to talk about verification in the context of crowdsourcing. So methodology versus technology. Right, so yeah, as the slide says, my name is Emmanuel. I work for Ushahidi. We are, so who are we? So we are a platform, a community, and a movement. A legally registered movement. So a platform, software that does information collection, visualization, and interactive mapping, a community of people that, working towards a common good, and also movement lowering the barriers for entry for sharing, stories. So I'll just get right onto it. So our software, or what our product has been used for, is varies in terms of use cases. So the genesis of the product, or even the organization and the community around it, is around elections. So during in 2007, there was following the post-election fallout in Kenya. So a group of people got together who are the co-founders and put up a map that would show where most of the violence was taking place. And so in that same kind of spirit, or that kind of motivation, so it's been used for election monitoring. So this is a demonstration of what it was used for, how it was used in the August 2010 referendum when we were passing a new constitution. So the idea behind this was working with various election monitoring organizations that are on the ground, that are placed all over the country, so as to get what was actually happening, so that to ensure that the election process was being conducted in the manner that people are expecting it to be, which is free and fair. This is in Russia, where a group of volunteers, again, online community, got together so as to map the needs of those people that needed help with those that could provide help. What was interesting with this was that, in as much as the wildfires had struck, the Russian government was caught totally unawares. They were not prepared to handle that kind of situation. So people got together and decided, these are our own people that are being endangered by these fires. It's a property that is getting destroyed. So they crowdsourced the, purchase of equipment, firefighting equipment, and even how to rescue people from wherever they were. Moving on, this is Harass Map in Egypt. So this was actually getting stories from the ground via text message on sexual harassment. I believe the deployment is still live and going. This again is another use case, which is in Japan last year, the earthquake and the tsunami. So a group of technologists and volunteers in Japan got together, put up a map, a deployment to show exactly where most of the damage that's taking place, and the needs of the people that, matching the needs of the people on the ground, and of course with the available help. So moving on to verification, trying to demystify what this is. So as per the Oxford English Dictionary, it's the process of making sure or demonstrating that something is true, accurate, or justified. Yeah, that's the definition. So there's some considerations when it comes to verifying a piece of information that is coming from the crowd, or in any kind of context. So especially with the crowd, there's a question of anonymity and privacy, and this is very key, especially in conflict situations. For example, in as Rob mentioned, in places such as Egypt, or even in Libya, Egypt, or Syria, divulging information that is considered sensitive could endanger the lives of those people. And then there's trustworthiness of the individuals that are actually providing you with this information. And then there's triangulation. Are you able to corroborate this information that is coming from one individual against other sources? Or does it seem to be a recurring theme, or is it just an isolated incident? Is it an outlier? And then there's stakeholders. Mind you, this is not stakeholders in terms of the ones that are eating meat, but people that you actually that are part and parcel of the process. And then of course motivation of the authors. There's people who of course will provide you with information for nefarious purposes. So that's also something else to consider when you're engaging in the process of verification. So this now is to talk about the model that the platform uses. So how we present verification is a yes or no answer, but still that doesn't suffice. Much of the work happens outside the platform, outside the software. So phoning people on the ground near reported incidents, checking with media reports, and maybe other organizations that are closer to the situation or are more specialized in that particular kind of scenario. So, and this is just to illustrate the kind of workflow that there is. So at the center, is a particular deployment of that crowdsourcing effort. And then you have, of course, the network of volunteers. There's the people that are affected. There's responders. There's public news, maybe providers, producers, and consumers. So whether it's media organizations, and of course, the consumers is the public, and anyone else that is tracking that particular kind of scenario or crisis. So just to give a quick run through of the kind of verification workflows or models that have been deployed or people have used in various situations. So looking at Haiti, again, back to what Rob mentioned, there was some sort of workflow in terms of how information would move from one person to the other. So as you heard, information would come in Creole, and then of course it has to get translated into more standard language, which was English. And even in as much as this was still taking place, there's still a way of which to verify exactly what someone is referring to. So either it's phoning them or that kind of a thing. And then of course is the other example here is Libya. So you have at this time there was a media monitoring team, and then a geolocation team, and then a reporting team, verification team, tech team, a tasks team, and an analysis team. And of course, now this were all coordinating with the UN OCHA team, and then providing or uploading the information on a deployment of Ushahidi. So this graphics may not necessarily display the intricacies of what is involved in verification, but it just shows that the methodology is largely outside the software itself. Yeah, which is something that is going to, I'll talk about in one of the next later slides. So one of the challenges that we've had, with this kind of model is, it's overly simplistic. Verification is never, a question of yes or no. I believe even people who are in the media, they have their own kind of debates as to what actually counts as something that is verified. So sometimes you'll hear when you're watching or listening to news that, unverified reports of this and this have come in. So probably what that means is that they have information that is giving them enough confidence to talk about it, but they still haven't, the information or the level of confidence has not reached, the certain benchmarks that they may have set internally. So you find this becomes an area of contestation, especially where there's a number of stakeholders with varying levels of reputation and risk are involved. So, back to like the crisis kind of situations where lives are really in danger, especially when, people are revolting against the government. So when you say that for sure, maybe, someone has, God forbid, been shot. So depending on who is actually giving the stamp of authority on this information, this can be very sensitive. And it's not just a question of yes or no. So this feeds into the next point, which is the need for verification workflow. So this is something that, of course, the people that are monitoring a particular situation, it's up to them to actually design the verification workflow. And then for us as technologists is to provide ways in which that verification workflow can be accommodated on the system and on the software end, so that actually over time you can be able to see X number of reports or X number of incidents had left this level of verification, or this number was completely verified. And then, of course, this model doesn't scale where there's a large volume of reports, because what happens in that case now is people start focusing on debunking all the noise from the information. So you have all this data that is coming in, but your priority now becomes, you want to separate the good information from the bad information. And that's where automated techniques come in. Computers have become pretty amazing nowadays. So it's fairly simple and inexpensive to have an automated system that can help you reduce your signal to noise ratio. So, and actually regarding the first point, this was very evident in the Christchurch earthquake in New Zealand last year. So the government was very was holding back on participating in the deployment, because they didn't believe in being a signatory to something that didn't have some sort of government approval. So the team there probably had to think about having a category such as this is government verified. So this speaks volumes about where this kind of model doesn't work. When you have so many stakeholders with varying levels of risk and reputation. So some of the lessons we've learned from all this is that design the methodology outside the technology. Don't let the technology be a barrier to your methodology for verification. Yeah. So have the methodology outside, divorce it completely from the technology, and then when it comes to the technology and design for verification for these kinds of systems. So design the system in such a way that it's very easy to incorporate a verification kind of workflow. The third thing is Occam's razor. I believe there's a good number of academics here. So Occam's razor is, take the simplest approach is always the best. And then, of course, you iterate and adapt as needs evolve. Verification is not cast in stone. It's not a model that, one model that has always worked across all kinds of situations. Verification models will vary from one use case to another. So as those kinds of needs evolve, so you also adapt either it's a technology or even the model itself to cater for that situation. And then lastly, the other point is, a map is only as useful as the process and the people that make it happen. So this is a quote actually from one of our volunteer developers or a member of our community. His name is George Chamalis, and he runs a company by the name of Rogue Genius. And then, of course, the power of collaboration. So we collaborate with, a number of organizations out there because, again, sometimes you need to scale and get insight from different kinds of organizations or individuals. So top on the list there is OpenStreetMap. Again, my thanks to Kate. And then this Frontline SMS. This is also a nonprofit tech organization that has a low-cost, actually, a free software for SMS messaging or aggregating SMSs. It runs straight out of your computer. So it's really built for those situations where you don't have any kind of internet connectivity. And then there's a standby task force. Thanks to Helena right there. So this is a network of volunteers that get activated according to the various protocols. She'll talk more about that. And there's also the Social Development Network. This is an NGO in Nairobi or in Kenya. usually referred to as SODNet. So this was one of the organizations that was very instrumental during election monitoring kind of situations, because it's an area that they have expertise in. It's an area that they've been practitioners in for a while. So they would know the kinds of organizations to get in touch with so as to get first-hand information that is as accurate as possible. And there's a question, of course, of trust. If you're verifying any kind of content, you must be able to trust someone. So there's a trust breach. So for any of these kinds of initiatives to be successful, then people need to have confidence and faith in the people that are running that kind of initiative, that kind of project, that kind of deployment. Because if they don't have that kind of trust, then it's very difficult for people to provide you with information or good information even at all. Case in point, this year, the government back in Kenya warned a couple of residents in an area known as Mlolongo, just right after the airport, of the impending doom that would come with the rains, or the impending destruction that would come. So the government was there way in advance to tell people that where you've constructed is probably not the best place to construct, and you probably need to start thinking of moving before the heavy rains come. So because of the kind of image that has been cultivated about most governments in Africa of being corrupt or being inefficient, people of course didn't trust this kind of information that is coming from the government, in as much as it was very accurate and was clearly going to affect their lives. So people didn't move. And of course, the fact that a couple of demolitions had taken place in that area a couple of weeks before really didn't help much. And trust me, when the rains came, there was a destruction of property. So I think also this ties into what was mentioned yesterday during the introductory remarks, that over the next couple of years, that trillions of dollars or trillions of truckloads of money is going to be poured towards infrastructure projects in Africa. But there's a good chance that that money is going to go to waste, because people are still engaging in this developments in areas that are still disaster prone. So again, it's a question of act now as opposed to acting later. And then finally, you can only do so much in technology, but then the technology is there to work with people, or people to work with the technology. So you can only allocate so much attention to the technology, but if, again, you don't engage the community or the people that are involved, then it's probably going to go all to waste. So this is a Venn diagram that was done by a gentleman by the name of Chris Blow. So he says that 20% of the time or 20% of the effort, let that go to the setup of the technology, but allocate 80% towards making whatever you're doing a real success. So that's whether it's operational kind of work, where you talk to media or other organizations that can help you collaborate in your effort. And that's it from me. Thank you.
Hi. So my name is Elena Puch-Larrauri. I'll forgive Kate for butchering that. And it's not the easiest. And I started this thing called the Standby Task Force together with a few other colleagues and friends, including Rob Monroe, who's actually also on the panel. And I also, this is what I do in my spare time, I am also, in my work time, a peace-building practitioner. So I worked for UNDP Sudan until last Thursday, until quite recently. And I'm very glad that I came after these two presenters, because what I want to talk about is the use of crowdsourcing in conflict settings, which they've both touched on to a certain extent. And I wanted to start off by flashing up here what is my favorite definition of what conflict is. And I like it because of its complexity and because it shows that conflict is not a very narrowly defined thing like a war or a set of violent incidents. That conflict is a number of things and is in a lot of the operating contexts that you all work on. And so it's just as important in a disaster risk management setting as it is when we talk about peace building. And so this is why I wanted to introduce by saying, I know I'm going to talk about conflict, which is what I know about, but the reason that I wanted to bring it up is because disasters do happen in conflict settings. And so if you're considering using crowdsourcing in a disaster management, in a disaster response, then to be aware of what the additional complications are if it's a conflict setting is probably important. So that was the motivation for this presentation. And so I thought what I'd do is I'd tell you four stories, two that I think were largely successful, and two that I think were largely a failure. All of them happened in a context setting, as you see from the countries that are up there, and then try to unpack why they were a success and a failure and what that teaches us about how to operate in conflict settings. I just want to say, this is not, I haven't done a rigorous analysis of what the success and the failure was. And Rob mentioned earlier that he considers that the Libya crisis map, which is one of the examples that I would give, was a failure because it was very inefficient in terms of the use of time, which I actually don't disagree with. As it happens, the reason that volunteers were used is because there was no one to be paid for this. So for me, it was a stopgap measure. I think there are more efficient ways to do this work, and I very much hope that you and OCHA will take those up. But as a stopgap measure, volunteers were the best that was out there. And so when I say success, I guess largely what I'm talking about is that the clients or the people who were using the information that was crowdsourced said that it was useful to their operations, and that we don't think that there were any major operational difficulties or operational concerns with the deployments. Whilst in the other ones, either they were not useful or there were such big operational constraints that we never got them off the ground. So let's start with Somalia. In Somalia, there was a drought in the Horn of Africa, as you may all know, and we were asked to crowdsource the location of shelters in Somalia's Afguye corridor. I may be mispronouncing that. Which would be a way of helping UNHCR make population estimates so that they could better deliver aid in that area. This corridor was an area where a lot of people were being displaced in this period, and where UNHCR was having difficulty getting population estimates. So this is basically a satellite picture of the corridor that we were asked to look at and that we were asked to map. We got the imagery from Digital Globe, and then a company called TomNod developed a small application that would basically help us to divide that corridor into tiny little squares, which are those yellow dots that you're seeing up there. So each one of those squares is one picture of very high resolution satellite imagery. And so what we would do is TomNod had a little application that our volunteers would log into, and they would be presented with one of those little squares. And on that square, they would be asked to find shelters. And so they were given a number of examples of what shelters would look like in satellite imagery. And then they would find them on the picture, and they'd literally tag them. And then once they were done with that, they'd move on to another picture. What you see at the bottom is what it looked like once it was done, with all of the tags on it. And so we did this over 5 days with 168 volunteers, and that's the number of satellite images that they were looking at and the number of tags that they produced. For a tag, there was also a ranking algorithm that would tell us basically whether these tags were correctly done or not, and you would need to have a number of volunteers agreeing on a tag before it would be something that we'd send over to UNHCR. UNHCR still then had to go through that data, but basically we did some of the legwork for them. And I guess for me, this is an example of where a mass human intervention is necessary. So crowdsourcing is useful until the software catches up. Eventually, this will be done by software, we would hope. But at the moment, it was not something that could be done. Okay, so that was the one that worked. And now here's the one that didn't work. We were contacted by a big humanitarian organization that was working in Syria. And what they were looking for was they wanted to do a map of the location of health facilities and whether they were working, so their functionality. And they also wanted to tag to those health facilities whether there were any rumors of outbreaks of diseases around those facilities. And they wanted to use local informants from Syria to do this. So they wanted people to report on whether the health facility close to them was working or not and where it was. And we never did this. We turned it down, so I don't have anything else to show you apart from this picture from Google, because we considered that both, given the security or the insecurity that we would be placing the local informants in, and also the politics of saying that a health facility was functioning or not, and what position that would put the response organization in, were too complicated. So we dropped it completely. So just kind of basically the same kind of thing that was being done for Somalia in that it was just location of facilities, but this one was much too controversial. And then the next pair of sort of success and failure are slightly more complicated situations. We were asked by UN OCHA to support in putting together a Libya crisis map that collected contextual information on Libya when the crisis first happened. Literally what the definition that they gave us is they wanted to understand what was happening on the ground in order to support humanitarian preparedness. That was more or less the brief that we got. And in addition to that, they also wanted to get an understanding of who was starting to do what responses. So if any of you have worked in a humanitarian context, you know that UN OCHA produces these three Ws, who, what, where, maps or databases. And so what we were asked to do was to help them to produce that 3Ws information. And we were to do this by looking at traditional media, at social media, and curating it and verifying it using some of the techniques that Emmanuel mentioned. And then eventually we also started to get direct information from NGO workers and journalists who were working in Libya or on Libya. So I guess the main thing to say on that is that we didn't have any on-the-ground informants. We were going purely on English secondary sources. And what we were doing really was curating data, not collecting data. And that's what our volunteers were tasked to do. I think OCHA found this useful. That's what they told us. I put this up because this is probably the most, the shortest message that we got in recognition to what we did. We got a number of emails also from some of the people who were using this map, saying that the map, the OCHA email in particular, said that the map had reduced the information overload of its staff, had produced an output that was manageable and digestible, and had led to better planning and decision making. Exactly how that happened, I don't know, but that's what they tell us. We also had contact with WFP, UNHCR, IRC, and the Red Cross, all of whom said that they had been looking at this map and using it for some of their planning. So that was Libya, which worked relatively well in the use of crowdsourcing. And now I want to talk about something which isn't actually the standby task force, but just because Sudan is close to my heart. So this is what I spent 3 years doing, which is going around and talking to people about conflict and getting their perceptions of conflict. We did very sort of traditional conflict mapping and peace building responses, which are based on going out, running focus groups like this one, and then getting as much information as we can and trying to respond to what's happening on the ground. The problem is that this happens a lot of the time. So this was the drive back after that workshop on the ground. The road has disappeared and we're in the middle of the mud. We're never going to be able to get back out there to find out whether some of the concerns that these people had actually turned into something that happened. And so what we started doing in the project I was working with UNDP was trying to explore whether there was a way to use crowdsourcing to develop a conflict early warning system. So basically, a way that we could use text messages largely. There's a very good phone network in this area to get people to text in with some of the concerns that we were discussing with them in focus groups. And we didn't get very far at all. We got as far as designing some of the pilot materials and thinking through what the system would have to look like and what kind of crowdsourcing we would be doing. And very quickly, the government shut it down. Which is not surprising, given if you know anything about Sudan and what is happening at the moment, there's a very tight control on information. So even though some of the questions that we were asking, I don't think would have put our informants in danger, there was another issue, which was an issue of political space. So the government did not want this kind of information to be exposed and to be publicly shared. And so again, this is something which got nowhere. So the reason I gave you 4 such different examples is because I wanted to make a very clear point that I don't think that whether crowdsourcing works or not in a conflict setting has to do with the complexity of the data that you're collecting. So it can be as simple as tagging health facility locations, and you might not want to do it. It can be as complicated as gathering contextual information after a crisis has just started, and it might be actually okay to do it using crowdsourcing. The key difference is around the ethical questions that you ask about whether you should be using crowdsourcing or not. So for me, these basically break down into 2. The first one, and what I'm quoting here is the ethics code that we make all of our volunteers sign in the standby task force before they start doing any crowdsourcing work. And so the first one is around safety, and the safety of affected populations that are either the source or the targets of the reports and of information during a specific disaster. So this, for me, is a very important principle to keep in mind whenever making any decisions about the use of crowdsourcing, particularly in a conflict setting, although it has applications directly to disaster response also. And behind it is the principle of do no harm, which I'm sure that everybody in this room is familiar with. And for us, the key questions were, was anything of what we were doing affecting or giving fuel to dividers that could be making the conflict worse? And was the information, that the way that we were crowdsourcing information, having any effect on connectors in a positive way? Now, these are always subjective decisions to make, but I think these are 2 good benchmarks and informed a lot of the decisions that we made on whether to use crowdsourcing. And then the second one is around neutrality. And I think this one I put up here because it speaks to the Sudan example that I gave very much. I think a lot of what can happen with a crowdsourcing project is it can be instrumentalized for one political aim or another. And that can be from the government, it can be from activists who become involved, it can be from some of the volunteers that are involved in the crowdsourcing. And so bearing in mind the issue of neutrality and retaining and holding this principle very dear while you're trying to implement crowdsourcing projects is very important to us. I think I'm going to leave it at that. I think just one final comment, which I should have said somewhere along the line. One of the things that I've learned in trying to answer questions around whether crowdsourcing is an ethical solution in a conflict setting is that usually the people on the ground have a better sense of the safety and neutrality concerns than any volunteers online. I know that's a very obvious point, but it's one that we sometimes forget. And I recently heard from some of the activists that are running a crowdsourcing project in Syria. And we were asking them, aren't you worried that the politicians are going to use this, or that the opposition is going to use this, or that I don't know who is going to use it? And their answer was very simply, they've already got all the information they need. This information that we're collecting is for people who don't have it already. So I'll leave you with that.
Okay, my name is Shannon Dosmegan, and I work with Public Laboratory for Open Technology and Science. And I'm going to talk about what could be called crowdsourcing from a bit of a different perspective. I'm going to talk about Public Lab, which is a community that's putting their heads together to develop open hardware solutions to environments that are in crisis. So Public Laboratory currently is a community of about 500 to 600 people, online, offline, and local communities across the globe that are collaborating on building low-cost, do-it-yourself, open hardware, open source tools, both software as well as physical things that can address environmental problems that we have. We are a very diverse community of people that includes social scientists, natural scientists, biologists, wetland specialists, technologists, hackers in the traditional sense, designers, makers, doers, right? And so what we're looking at is we're approaching looking at what is traditionally called citizen science, or sometimes we also call it crowd harvesting, and trying to figure out how we can come up with solutions to the problems that we're looking at. Typically, the way that projects are developed are by researchers in academic settings where they'll pose a problem and ask people to just contribute information. So there's really no feedback loop, and there's no real engagement from the ground up from people in what is happening in their very localized context. The solutions that are being posed are also very expensive. They're limited, again, to the hands of experts. There's also a lag in knowledge between experts and people that are on the ground in communities. People on the ground also don't own the data. It's owned by the people that are posing problems for them to solve. And because of that, they also don't always understand how data is being developed and collected and made. And as well, we work in a lot of communities that are facing issues with industry, whether it be oil and gas or coal in the United States, and find that industry has a far greater capacity to generate data. And because of this, also, many of the tools that are being used and that are available are based on industry standards that are trying to push barriers rather than looking at the environmental health of communities. So what the civic science approach, and we could talk about crowdsourcing in this aspect, to environmental health monitoring poses that it's community-oriented and developed. It's also community-owned, so that people have full ownership over the data that they're collecting. Tools can be adapted in an open-source fashion, and this is kind of a very viral thing that I'll go on to describe as being infectious and a good way to spread knowledge. And it also supports public exploration and investigation of environments and treats locals as the experts in their own environments. So I'm going to give an example. I'm from New Orleans, Louisiana, and during the BP oil spill in 2010, we started using our first tool, which was mapping the oil spill before, during, and after it started hitting the shoreline with balloons and kites. So this is what our tool looked like. This is one of the first trips that people took out. It's basically a kite. We have a camera, and the camera is set inside, in the United States, we have 2-liter soda bottles, but it's the top of a soda bottle. And the camera is put on point and shoot mode with a Q-tip and a rubber band. So in the tradition of making this as low cost as possible, this tool is available for about $100. It's something that anybody can go to a local hardware store, drink a bottle of Pepsi, drink a bottle of Coke, take a Q-tip from your mom's bathroom, and you're ready to go. You can use an old refurbished camera. The ones that we use right now are $50, and you can collect incredible images. And so what we were responding to with this project, we ended up with about 250 different people coming together to begin collecting images of the spill. And the reason that we did this was because people saw that there was a lack of access. There was a media blackout that was coming because BP was really controlling all the information inflow and outflow. There was also a flight cap, so planes could not fly below 3,000 feet, which made it really impossible for people to get good images of the spill. However, fishermen, fisherwomen, college students from Tulane, college students from UNO, regular community members, NGOs, were able to go out on boats and put balloons or kites in the air at about 2,000 feet and capture images. And sometimes on each of these, they would capture about 1,500 different pictures, which we could then stitch into maps. So this is an example of an IRMA database, and this is a picture of Barataria Bay from July 22nd, 2010. And this is traditionally how NGOs work, where they have to go to different government sources and beg for data. And so in this image, we see the red lines are showing heavy oiled coastline, and in the light green that's kind of in the, okay, you can see it good. That is indicating very light oiling. So that exact same day, there was a group of about 20 people that went out with a kite, and they put it up over the exact same area of land, and they got this image, which shows that there's a bit more of a difficulty in discerning what is actually heavily oiled and what is actually very lightly oiled, and contradicts actually what the IRMA database was saying. And so this is a way also that people were able to go out and do ground truthing. And so, let's see, the right-hand side, you'll see some squiggly white lines. That was discarded boom where oil was coming in that the IRMA database was not able to pick up. And this image was also documented at about 2 centimeter pixel resolution. If there's mappers in here, you might know that's pretty decent. So the way that we're able to work with this technology so successfully is that we use a number of different open licenses. So the very newly derived CERN open hardware license, which is applied to actual hardware products, and this came out in the last year. A Creative Commons share-alike license, which we applied to our software products, and the GNU public license. And we call these infectious because it really, being able to open up our designs, being able to put our design models on our website, people posting research notes when they change the design, allows this to spread all over. So we started in the Gulf Coast 2 years ago, and since then we've spread to numerous locations around the globe. Rio de Janeiro, Santiago, Chile, where they documented the education reform protests using a similar technology, Colombia, Jerusalem, the Czech Republic, where they looked at illegal logging activity. So this is just an example of one of the ways that this open hardware, open source licensing has allowed people to completely alter the design. This is the soda bottle rig that I was talking about that we stick the cameras in. And the very first design was the one on the second to the left on the top that I'm holding, which started out with cardboard wings. And so in the humidity of the Gulf Coast, it's really wet there. The cardboard didn't stand a chance and kind of came down floppy. And so because of that, people wrote in and said, well, obviously we have to come up with a new design. And from that developed the much more stable yellow version, which incorporates plastic wings. So from that, what our community decided was, okay, so we have all these images. We collected over 200,000 images during the oil spill. What are we going to do with this? And so we started building websites. Public Lab Archive, which is based on data.gov, is taking back the images and the maps that were created and putting them into languages of power like GeoTIFFs and TMS and things that cartographers can understand and use. And so this is an example of what the system actually looks like. It's a forum. It's built on a wiki and a Drupal platform, which allows people to rewrite the pages, leave their notes, give conversations, tell stories, post videos, and really contribute to what was happening at this exact time in the Chandler Islands in Louisiana. We also have had to take it a step further, or some might say take it a step back, and do print publications as well to figure out how to best reach communities that we're working in. In rural Louisiana, a lot of people don't have strong internet access, and so by posting maps on newsprint and putting them out in marinas and gas stations, grocery stores, we're able to get a better reach. The Siam map that you can see was meant so that people could, when they're going out to check on oyster beds or other areas around Barataria Bay, they could write in what they were seeing and it could be posted back into the website. So this was an additional way to generate knowledge from communities. So I'm just going to talk a tiny bit about two of the other tools in the context of how kind of open source has transformed the work that we've done. We currently have 12 different tools that are being developed, which include air column monitors, thermal flashlights. We're looking at heat leaks, infrared camera, which I'll show you in a second, water sensors. But the first one is the near-infrared camera that we've been working on. And so doing restoration efforts in Louisiana post-oil spill, this was something that people said was really needed. And so what the community figured out is they could take the same $50 camera that they've been using to send up an aerial rig, they could open it up, they could take out the infrared filter, and they could put in a piece of exposed film, and you would have a near-infrared camera that would look at how plants were photosynthesizing and be able to show the vegetative health that was in an area. So this would be an image that you would receive on the left-hand side. If you flew a dual rig, you would get one image that would be just visible light. The bottom one is the infrared light, and you put them on top of each other, and you get a composite infrared image. And in the image on the right, this is a project that people are doing in the Gowanus Canal, which is it's an Environmental Protection Agency Superfund site, which means a site of really deep industrial contamination. And they were able to detect an outflow with the infrared camera that had not been previously documented on EPA surveys. And then just to give a very localized example as well, one of the other systems that we've started developing around mapping started with the gentleman in the right who is part of a bucket brigade. And bucket brigades use low-cost tools that are based on EPA SUMA canisters. But the one that he has is $75 as compared to a $2,000 SUMA canister. And what these do is they take quick air grab samples, and you can send them into a lab and test them for a number of different chemicals that are in your air. So people around industrial facilities all over the world are using these. I know in South Africa, communities in Durban use them. The problem in this area, they're in rural Colorado, and to get a test for hydrogen sulfide, they had to send the sample to the lab within 24 hours, which was nearly impossible for them, and the sample cost upwards of $500, which was also cost prohibitive. So one of the things they said, these are old contacts of some of the people in our community, is that we really need an easy solution for testing for hydrogen sulfide to tell us if we then should use the bucket, if it is worth our money. So Public Labs community has been working on this project now for about a year, and we started in the right-hand corner working with industrial hydrogen sulfide sensors. And from there, people started suggesting that there was a much cheaper method, which we've since started working with, which is using Ilford black and white photo strips, which are put in photo flow and glycerol, two very cheap chemicals, and will expose when there is hydrogen sulfide present in the atmosphere. And so from this, after doing storyboarding with communities in the gas patch, so this is communities that are located next to hydrofracking operations throughout the United States, they decided it would be interesting to begin mapping how chemicals were released throughout communities. And then just a final example of, through research, how people are collaborating by contributing a number of different research notes and iterations. And so every time someone reads a new article or has a conversation or, does a test and something fails miserably or succeeds wonderfully, it is documented and left on the website so that people going forward can contribute and continue to grow on the knowledge that's already there. So in this project, for instance, we have participants throughout the United States in the West, Texas, New Mexico, Ohio, Louisiana, and it includes people such as retired engineers and landowners, hydrogeomorphologists, anthropologists, design students, and researchers in the wetland areas of Louisiana. And so I'm going to leave you with that as kind of a different example of what crowdsourcing is. And please feel free to contact me with other questions.
I'm going to talk very briefly about a tool that the Humanitarian OpenStreetMap team developed in partnership with AusAid to help collect base data for preparedness. And just a quick reminder, so OpenStreetMap works like Wikipedia. It's a free map of the entire world. Anyone can contribute information to correct errors, add missing data, etc. So So traditionally, though, it's sort of go work on the area you're interested in, which we found it was difficult in response situations where we collected base data, for example, in Haiti, to say to a large group of people that wanted to help, just go find somewhere blank and start mapping. So to get around that, we created this tool. We call it the OSM Tasking Manager. And what it does is it allows an administrator to create a specific thing they want the group to do, describe it, and then volunteers can log in and look for tasks to do. So one example is we bought imagery of Padang City in Indonesia, in Sumatra, and we wanted to map all of the buildings in the area. So that could feed into impact models and help develop contingency plans. So here we, as you can see, it creates a grid basically, and someone can then select that grid to work on. So someone would just be logged in, select this task, click take a task, and then they're taken to this screen where it shows them the area they're going to work on, and then they can pick a specific tool in OpenStreetMap to go do the editing. And so say they clicked on this, it'll then take them into a specific editor. You can begin following the task if it's add all of the roads, add all of the buildings. Could be to map rivers or streams, things like that, depending what the purpose is for the preparedness. And after that, they can go back to they can go back here and say that they're done. And if you look back at our task here in Padang, you can see there's green and red squares, and there's ones that are clear. So we've added both a saying you're done and also a verification step to this. So that way, two sets of eyes look at things. For example, there was a high school in the US in Red Bank, Tennessee that said, hey, we want to help with this preparedness exercise. But the guy leading them said, I don't know about letting a bunch of 15 and 16-year-olds map buildings if that's a good idea. But what we were able to say to him, though, is, well, we're going to do a verification step. And it actually turned out, I mean, the kids were fine. They did an amazing job, similar to what any of our volunteers were doing. But it allows a little bit more confidence that at least two sets of eyes are going to look at things. So through this process, we've mapped about 70,000 buildings, and it's been used in exercises in the area, and also feeding into impact modeling software in a SAFE, which you may have seen in some other presentations. There has been a couple things that we've actually learned from engaging people, though. The number one is high-resolution satellite imagery. A lot of things we do with this tool is showing people imagery, and they draw things out of it. To get volunteers to really want to participate, it has to be interesting to look at. Most of us have probably used Google Earth, so people are used to the idea of being able to zoom to their house maybe and see something very detailed. And they don't necessarily want to volunteer to help if it's doesn't look that good. That said, if the cause is really good, you can also convince people to do it. So either it has to be interesting or they have to be really engaged intrinsically. The other important thing is clear guidelines of what to map. If you're not telling people what to do very specifically, a lot of times they'll lose interest. People will come in really enthusiastic and say, I really want to help, but if they don't know what to do, they get frustrated very quickly. A third thing is information on how the data will be used. So if you want people to keep helping, they need to know why. That means, in this case, where we are outreaching to a large international audience, they need to know, well, is there some benefit? Are people going to actually use what we're collecting? If you're working with communities, it's more important, even beyond that, to help them be able to use the data as well. And finally, it's important to follow up on the results. You could probably get everyone together one time to map something like crazy, but if there was no follow-up, the next time you want to collect information, you probably won't have the same level of audience. So that was just a very quick overview of our tool. And Abby's going to come up next and talk about how that type of data can be used in DRR applications.
And I'm very excited to be presenting in this session. It's following on a number, the whole conference is really a great context in which to discuss these ideas and share. And it's a privilege to be on the panel with such a range of different applications that draw on this theme. So thank you, Kate, for allowing me to speak. And I'll be referencing a lot of work that was done as part of a broader collaboration. And so we also have Dr. Agus Wibowo from the Indonesian Disaster Management Agency and Trevor Dew from AIFDR, who are closely involved, along with Kate from the Humanitarian OpenStreetMap. So all the Indonesia examples, it's part of a much broader collaboration. So in the practice of disaster risk management, I want to try and focus on a couple of the key questions when we're thinking about how to use these tools. And I think throughout many of our sessions, we've been hearing a lot about how to map risk, how to identify what's causing the risk, who's at risk. And we have a lot of information that's out here. For example, in Indonesia, we have these very good risk index maps that are produced as part of national risk identification. Once we start to identify that there is risk, there's these questions then that need to be answered. What are we going to do about it? You know, how are we going to build, where are we going to build safer schools? How could we start to prioritize investments in retrofitting and in infrastructure? If we have to run a very detailed response, do we have the level of detail of information that we need to do this? And also, are we connecting with the same communities that would be critical in the response and in the risk reduction through this process, or are we leading a really exclusively top-down project? And so these are questions that at the bank are still being asked and still being answered. So this isn't a magic solution, but it's some of the different experiences that we're having. And in many cases, there's great options for tools and technology to help. And one thing through the Indonesia work in particular we found is that connecting in with practitioners and projects and organizations and movements that work at the community level offers a lot of value and increases the efficacy of our investments in disaster risk management. And again, I've stolen this slide, I believe, from Pa Agus, and that's just to make sure that we're all on the same page. We are here at an Understanding Risk conference, so I figured you couldn't walk out of a session without seeing the word hazard. But I won't dwell on the hazard, but we know that there are many complicated tools and valuable research that helps you characterize hazard. We know that we also need to know what's exposed in order to have an understanding of risk. So both of these are very key ingredients. And what we'll focus on is really the people and the assets and the buildings that are at risk. And there are many ways that you can start to collect this information, but it will really depend on what is it that you want to do. The question of where to build safer schools requires a certain data. Where should you locate your emergency response materials requires a certain amount of data. And there's a variety of tools that you can engage in when that information doesn't already exist. And some of the public sources and also tools like OpenStreetMap have been found to be very valuable. And so what I've learned in this process is that community mapping is not new. There's, through many other disciplines, community-based poverty reduction, I can tell in conflict resolution, it's required to work at a very high resolution and deeply engage with your communities. And so I think working already with organizations that have developed those insights about how to engage at the community level is very important. And they are mapping. They are creating spatial information. But how is that spatial information actually being captured? Is it being captured in a way where we could include it and incorporate it as part of a risk analysis? Is it captured in a way that that same community won't have to come back 6 months later and use their time to recreate it? These are things that now maybe bringing together all of the great social community development skills and technology together can help have an improved process. And so the example that I'd like to talk about is around Jakarta contingency planning. And so one of the other things was, and I think Kate touched on it, is like people have to know why they're helping and why they're being involved, and it's really good to have a strong purpose and a strong goal. And So the Disaster Management Agency of Indonesia, both the national and the province of Jakarta, were interested in creating a different type of contingency planning process this last year. So this is very new, and I don't know if maybe you can use your linguistic technology to translate if that Thai is really Department of Emergency. I know this is a picture from Thailand and not from Indonesia, but there was a certain amount of urgency following the floods in Bangkok that was felt by policymakers and the community in cities like Jakarta that you know that you're at risk, you know that there's flooding. So how can we start to have different processes that will put us in a better position instead of year after year kind of scrambling with the same decisions? And so these were a list that of the types of plans and the types of actions that needed to be taken, and we wanted to see what are the processes and tools that we could use to facilitate this. And again, it was led by the disaster management agencies. We also had support in this case from UN OCHA. And so this is where preparedness and response expertise was required in order to come up with a good plan. And so I've also started to realize that participatory mapping, some people have a very specific definition of it. Have you truly engaged openly with a broad set of community members? And so I'm thinking more, I don't know, I don't want to start calling things by the wrong name, but in this case it was more of a hybrid approach where it wasn't on an open volunteer basis. You didn't just walk down the street and grab people and ask them to help. Instead, this was we were thinking of it as participatory because we were enabling the local governments to participate. And in Jakarta, you have over 250 urban villages. I always get Kelurahan and Kecamatan switched, so I can't remember which one is the right unit. But there's a number of communities within the broader city of Jakarta that had never been engaged in a process like this before. It was also something that needed to be done very rapidly, and there needed to be very good quality of data. So all of those metrics around how do you verify, how do you assure, those are all very important if you want to use a process like this to inform very serious decisions to be taken by the government. And so what was great was that through over a year-long process that HOT and AIFDR had been involved with, there were trained university students who were already familiar with the OpenStreetMap tools for mapping and creating data. These university students then became part of this practice. They were paid, so this was not a voluntary basis. They were paid to work very closely with each of these local government officials in order to collect critical assets, schools, hospitals, places of worship, locations of response materials. And again, rigorous quality control is a high priority. And at this stage, and we also have colleagues from the Mapping and Geospatial Agency of Indonesia. I'm not sure if Pak Dodi is here, or Pak Agung, who also presented in one of the earlier sessions. But they've found this process of creating information, these methods, to be something that's very much in line with how the spatial data, the direction that Indonesia wants to go as a country, that they're able to take in high-resolution information that's been created from a range of tools with the participation of local governments. And so they're now engaging together with the National Disaster Management Agency to adapt and to refine this process to increase the quality and accuracy of the data. And so the output, and if you want to get personal with this map, Kate has a giant copy of it up in the Humanitarian OpenStreetMap booth in the expo area. But what this amounted to is that there were over 500 representatives from the urban villages. How many student volunteers? 70 student volunteers from the University of Indonesia. And they were able in a week, was it? It was a very short amount of time. More like a month. Okay, a month still. To map 6,000 buildings and critical infrastructure. And also what was something that maybe at first wasn't, you think you really need critical infrastructure. We're going to map all these points. But I think what also came out as a need is the sub-village boundaries had never been established. And in many cases, if someone is reporting a need or reporting, if there's flooding, they would use the sub-village boundary as a way to identify or to further identify the location within the village. And so establishing of those boundaries and mapping those boundaries, validating that with the heads of each of those villages to establish those, I think that's probably what took the most time from the whole process. And that was also something that the mapping agency found to be very valuable, and that this data will have applications and uses far beyond the contingency planning. So that synergy between something that was done for a specific disaster risk management purpose, but then has so much value at multiple levels, the community level, the local government level, and then is demonstrated through the engagement of the national agencies at the national level. And so, yeah, I think probably we now know about OpenStreetMap, but it offers a lot of very, very valuable features. And the active global community of users, as you can see, there's many projects and initiatives and tools that leverage OpenStreetMap around the world, open source, common platform for uploading and sharing data. But what was through the efforts of this over year-long engagement, there's now a growing community of practitioners and people who know how to use these tools and routinely access this information in Indonesia itself. And so there's resources. I think Bahasa was one of the third or fourth languages that some of the OpenStreetMap tutorials had been translated into. So this is all there for the sustainability of this process. That this wasn't a fly in, fly out. This is engaging and building capacity in a very meaningful way. I want to say that I happen to work in East Asia and the Pacific, so that's why I was sharing this example, but Africa is also leading the way in many of these initiatives, and I don't have them all there, and I definitely should have had Ushahidi on this list, and I should have just said and many more, but I should have explicitly put Ushahidi on this list. Apologies for that, but there are a number of active projects that involve community mapping. They don't all use the same tools. There's a range of tools, as we know. And it's not all for disaster risk management, which I think adds a certain strength to this, that you're working, you have to work, when you're working at the community level, you have to be driven by what is most important to that community. And so you might find yourself being part of a multi-purpose, and you should hope to find yourself being part of a multi-purpose action. But there's a growing use within the bank and outside of the bank, of course, too, for using these tools for risk reduction. And what I'd also like to say is that our interest as part of GFDR and the World Bank is that tools like this enforce and empower a very real need that we're trying to encourage, and that's part of the Open Data for Resilience initiative. And that's saying that the data and the information that we create to describe risks also helps you make better decisions to reduce it. And so developing and encouraging the development of capacity and interest in tools like OpenStreetMap is definitely part of that approach. And I guess there was a couple other things that I had thought of just while I was listening, and that especially at the bank, we don't see this as free work, that we feel people should be paid for doing work and designing programs. This is not something that just happens magically, and so we're helping when people want to add these elements into a bank project that they realize the resources that it takes, and that it's not just a cheap add-on, oh, you'll get a great data and maybe it'll make a good web story, that you really have to invest in these in a meaningful way. You have to invest in supporting the growth of the local tech communities that can make this work sustainable. So you don't want to fly in experts that will then fly out and leave the data, but that, like in Indonesia, you're growing a generation of practitioners and users who will be using that going forward for themselves. And the other one is supporting local governments to understand the outputs and understand the tools, so that it's something that does start to transfer up in terms of usefulness. And so I think that's what's been very exciting in Indonesia, is to see that a lot of this process now is being government driven because they see the value that's added from them. And yeah, the feedback loop. If once you start collecting data at the community level, that's the important thing about designing these together with government, is that they're in the position to have that be a cycle of community participation and action that actually improves their lives, reduces risk, and not just a way to I guess, data harvesting is what I would say. So thank you guys very much, and hope to talk more.
So we're basically out of time. Unfortunately, are there any last-minute burning questions? Everyone will be here for the rest of the conference as well, so obviously you can come up and talk to all of us. I'd like to thank everyone for coming and speaking. It's been really educational for me. I'm familiar with a lot of these projects, but I always learn a little more and start thinking of new ideas. So thank you. And I have one little administrative thing just from the conference organizers. If you could please look after your stuff, just to make sure you don't lose your laptops or iPhones or anything like that. Just someone left a phone downstairs and it's missing, basically. So just a reminder, keep your stuff with you. And thank you, everyone.